So, my dear Algebra 1 class, today we actually have a very difficult lesson to learn. So I think I'm going to do something a little different. Rather than having you do the questions themselves, I would like you to look at the answers for all the questions that I'm assigning to you. And then from those answers, figure out what is it that you're supposed to learn from this. Okay? It may sound complicated, but once you see it, it's not. Okay, so this lesson is on the transformations of exponential functions. I don't know if you remember, but a little while ago, when we were covering chapter 3, we studied the transformations of linear functions. And back then, we looked at straight lines. The blue line is the f of x, is the original line. And then we looked at another line that has been transformed from the parent function. Okay, so this green line is the transform line. So this one will be f of x is equal to x. This one will be g of x is equal to x minus 2. The minus 2 translates that line down 2 spaces. Do you remember that? Okay, I hope you do. These questions change the x. Okay, so it was translated or transformed, but this type of transformation is called translation. It moved right 4 places when you subtract the 4 from the x. And then there were other types of transformations like dilations and reflections. Remember, we dilated or they were compressed, right? Okay, these were like another, and then these are also other forms of dilation. And then there were reflections. Remember, there were reflections. So here's your original line, and the green line is the reflection across the x-axis. And then here is a reflection. This is the original line. This will be considered a reflection across the y-axis. Okay, so this came here and this came here. Okay, I know they look exactly the same, but they're not. Okay. So anyways, and then there were questions where you had to do reflections and dilations at the same time. So there were 2 transformations. Okay, these also, and then you had to analyze them. Okay, I'm not showing you these because I want you to memorize them. Okay, but as a comparison to what we're doing right now. Okay, we're now transforming exponential functions. So they're very similar to the linear functions in that you can also translate this blue line either up a few spaces. You see how where this blue and this red, there are a few spaces between them, or translate them down. Okay, you would add a cake to do the translating. If the k is positive, you move up. If the k is negative, you move down. And then here, you would actually change the x. Okay, so you don't just add a k or to the whole function. Rather, you change the x inside the function, so it's x minus h. When that happens, okay, you move that right. If you are doing x plus h, then you move left. Okay, so when the h is a positive number, you move this way. When the h is a negative number, you move left. But remember, if the h is a negative number, you would have x plus h. Okay. Here's another one. This is the translation of exponential functions. These are examples. So this, again, the blue line is where you start, and then this one moves down. Let's count. 1, 2, 3, 4. So it moved down 4 spaces, and that's where you have the minus 4. So the original graph is 2 raised to the x power. And then when you minus 4, you just move this graph down 4 places. The shape of the graph doesn't change. It just gets translated down 4 units. Here, As you can see, the x is in the exponential power space here. Okay, it's an exponent. So instead of raising it to the x power, you're raising it to the x plus 3 power. Okay, so the power is changing. So from this original graph of f of x, you're going to translate it left 3 spaces. Okay, so if you pick a point here, let's say you pick this point, and then you want to see how many spaces it moved to the green line, you go 1, 2, 3. Okay, if you pick it, if you look at something here, it's the same, like 1, 2, right? They all move over 3, but it's not as easy to look at that unless you're like right there at a corner. Okay, so these are the translations, and this is what happens to the equation. Okay, so I want you to look for these things. Here is one on, here you're going to analyze a graph that's been translated up. Here's another one that's been translated to the right. Okay, and then there are other ways of transforming, dilating. Okay, so I want you to like kind of read through these. Okay, so if you had an A in front, okay, so always the blue line is the original line, the green line is the transformed. So you want to see how it changed from the blue to the green. This one, everything's been squeezed, if you will, okay, up. This one says it's been stretched vertically, okay. So every point on the graph of f of x is farther from the x-axis. So where it used to be here, this xy is now being pulled up to here. Okay, they're comparing these 2 points, as you can see, whereas before, when the x is 1, okay, the y was here. But now, with the green one, when the x is 1, the y is up here. Okay. So this is called like stretch, a vertical stretch. This is a compression. So whereas here, this point is now down here. So it's like being stretched out. Okay, they call that compressing, vertical compression. So I want you to kind of look through this, and you're going to find that, okay, it's a little bit confusing. There's a lot of information here. And it's true, there are a lot of information here. But this is how I think you're going to be able to learn this lesson, is by looking at these answers. Okay, you look at the equation, and then you look at the description of the type of transformation that occurred. So if you look at this, if the g of x is equal to 4 raised to the x power plus 6, okay, the 4 raised to the x is going to be your parent graph, or the original graph. This part is the transformation part. So what does this mean? It means it has been translated up 6 units. That's what this plus 6 means. And then if you look here, it's going to say translated right 2 units. And where's that happening? It's happening right here. This is the x minus h. Okay, so if there's a minus 2 next to this x, that means it's being translated up 2 units. Right 2 units. It actually doesn't really matter what your base is. What you're looking for is what is happening, okay, in relation to this, okay, to cause the translation. And then you're going to look at other ways that it describes. This one is another translation. This one is going to be like a compression. So you want to look at it and say, what is causing that compression vertically? Compare that equation to this. Okay. When they talk about compressing it vertically. Okay, what is this A? Where is this A? Okay. So what's happening? Okay. And I'm sorry. This is about a horizontal compression. My bad. Okay, so if it's talking about a horizontal compression, I think the change is like right here, the 4 in front of the x. Okay. Compress horizontally. Okay, the x is actually being multiplied to a number. Okay, so when the x is being multiplied to a number, you're going to have a compression. Okay, horizontal compression. And that's what's happening here. You can see that your x has been multiplied to a 4. Okay, so I want you to look through these answers. I'm going to take pictures of these. I'm going to take pictures of these. And then you're going to look through these answers and compare them to your equation. And then see, like, what is it describing in that equation. Okay, I hope this helps. I hope this will help you learn this lesson, because that's what this lesson is really about. Okay, I will make another video to like go through the process a little bit, but first let me give you the tools that you need, basically the answers for you to do this assignment.